A car travelling at a constant 30 meters per second passes a police car which is at rest. After 5 seconds, the police car sets off in pursuit. He accelerates uniformly at 5 meters per second squared until he reaches a speed of 40 meters per second, and then continues at this speed. How long after the car passed the police car does the police car catch up? The important thing here is to decide what's meant by catching up. The police car will have caught the car when they've travelled the same distance from the point where the car passes the police car. The first thing to do is add the car to the velocity time graph. The car travels at a constant 30 meters per second. So if we mark 30 onto the v-axis, we need to draw a horizontal line from this point, since the car is going at a steady speed. So this line represents the motion of the car. Now we need to add the police car. The police car starts after 5 seconds. So we mark 5 on the time axis. He sets off in pursuit and accelerates uniformly at 5 meters per second squared until he reaches a speed of 40 meters per second. So 40 meters per second at 5 meters per second squared takes him 8 seconds to accelerate. 8 onto 5 is 13. So he reaches 40 meters per second at time equals 13. He then continues at this speed. So to complete the graph for the police car, we need the line where he's accelerating here, and then the line to indicate the constant speed from that point on. We now need to work out when they've covered the same distance. There must be some time when they've covered the same distance, and we'll call this time t. We know that the distance covered by an object displayed on a velocity time graph is equal to the area under that graph. For example, this rectangle is the velocity of the car. So the distance for the car is the area of this rectangle, which is of height 30 and width t, so the area of the rectangle is 30t. For the police car, we can split the area into a triangle and a rectangle. For the triangle, the width is 8 and the height is 40, so a half times 8 times 40 is 4 times 40, which is 160. For the rectangle, the width is t take away 13 and the height is 40, so the area of the rectangle is 40 times t take away 13, and we can expand the bracket to get 160 plus 40t take away 520. We need these two distances to be the same, so 30t is equal to 40t take away 360, just tidying the expression, and we can rearrange this to give us 10t is equal to 360, and therefore t is 36 seconds.